Hello ma'am, I am Gamya Charita from second year CSM A section. I am here to present my video assignment and my topic is dominance property. Introduction. Dominance property. If all elements in a column are greater than or equal to corresponding elements in other column, then that column is said to be as dominated. If all elements is less than or equal to the corresponding elements in another row, then that row is said to be dominated. Dominance property for rows. If x is less than or equals to y, that is, if all elements of a particular row x are less than or equals to the corresponding elements of another row y, then delete row x as the x row is dominated by y row. The elements of particular row x can also be compared with an average of two or more other rows, and if elements of row x are less than or equals to corresponding elements after taking the average, then delete row x. On moving to the next slide. Dominance property for columns. In before slide we saw dominance property for columns. Now we will see the dominance property for columns. How it will work? If x is greater than or equals to y, then that is if all the elements of a particular column x are greater than or equals to corresponding elements of another column y, then delete column x. Column x is dominated by the y column. The elements of column x can also be compared with an average or two or more columns, and if all the elements of column x are greater than or equals to corresponding elements after taking the average, then delete the column x. On moving to the next slide. The question is, solve it optimally by using dominance principle. The following table represents the payoff matrix with respect to player A. Here are player A and player B. The payoff matrix is here. On moving to the next slide. The solution is followed by step, and the first step is identifying dominated strategies. Take the total of each row and select least among them. First we have to calculate the sum of the values in each row, and we have to write on the right side, that is row total. For example, 4 plus 6 plus 5 plus 10 plus 6 is total 31. Similarly for all rows calculated, then we find the last row sum is, fourth row total is least, and we strike off the row and we compare first using dominance property for row. Elements of row are less than or equals to the elements of row 3. Then we eliminate the row 4. On moving to the next slide. Eliminating more dominated strategies. Select least value among the row total and apply dominance property. Here and the next. After removing fourth row, and the next least one is first row. Using dominance property, row 1 is dominated by row 3. That is, in row 1 all the elements of row 1 are less than or equals to row 3. So we eliminate row 1. On moving to the next slide. The reduced matrix is here. Second row and third row are remained. In this slide we check for rows. We check for columns. Here we compare each column, and we finally obtain C2, C4 and C5 are greater than the elements of equal to C1. These C2, C4 and C5 are greater than or equals to column 1. So we eliminate C4, C2, C5. Then on moving to the next slide, the reduced matrix is 7, 5, 8, 11. Here we can understand we identify the row minimum and column maximum. From the first row, we obtain row minimum is 5. We compare among these two elements 7 and 5. Here the minimum value is 5, so we consider 5 as row minimum for first row, and similarly for the second row 8 as row minimum. And we check the column maximum. Here we take the maximum value of the column, so we get 8 as the first column maximum. Next we get 11 as third column maximum. On where minimax equals to maximum, we have to check either this condition is satisfied or not. Then therefore the saddle point exists. If the minimax is not equal to maximum, then the saddle point does not exist. Here the problem is not will not get the optimal solution. Then value of the game is 8, and the probability of player A is 0, 1, 0, 0, 1, 0, and the probability of B is 1, 0, 0, 0. On moving to the next slide, conclusion. I hereby conclude that the dominance property helps simplify the complex playoff matrices. Iteratively eliminating dominated strategies leads to the optimal choice. In this case, player A should always play A3 for best outcome. In the given payoff matrix, the player A should always play with A3 strategy to get the best solution or best outcome. And thank you for giving this opportunity.